Hi and welcome. I'm trying to learn particle physics. Today, a hierarchy problem. And after we've done it, we're going to do standing yoga. And if you participate in the standing yoga, then it's better to out with it. The hierarchy problem. The very boringness of the Higgs boson's properties leaves physicists facing an elephant in the escalator tunnel. If it is the standard Higgs, how can it even be there in the first place? To most of us, the mass of an eyelash seems like just about nothing. But to a Higgs boson, it might as well weigh a ton. If the mass of the Higgs were as large as an eyelash, the world would look very different. The electrons buzzing inside a computer's circuits would be as weighty as the dust coating the top of it. If the dust piled up on the same scale, each speck would have roughly the mass of a well-fed elephant. This might seem like idle and rather surreal picture painting, were it not for the fact that the standard model suggests the Higgs boson should probably have about the mass of an eyelash. Under the rules of quantum field theory, it can temporarily shapeshift into all sorts of other particles, acquiring their masses in the process. So the first thing is that the standard model says that it has the mass of or gram or whatever, which is incredibly heavy for an atomic particle. And they're saying, according to the rules of quantum field theory, it can shapeshift into all sorts of particles and then have their masses. These interactions should make its own mass balloon from the region of 100 gigaelectronvolts its actual measured mass to 10 to the 19th gigaelectronvolts, the eyelash level. Okay, so it was calculated when we found it that it has around 100 gigaelectronvolts or 125 gigaelectronvolts, whatever that is now exactly, it is very, 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 very little. Now, if it has the possibility to acquire the shapes of the other particles and the masses of other particles, then it could get 10 to the 19th gigaelectronvolts, so a billion times a billionth of the mass it has, which would be 1 gram or something. This is so big that it would produce fundamental particles almost so massive and dense that they would create a microscopic black hole every time they collided. So we're saying, if it would work with if the particles would come together, basically, they would be so massive if they had 10 to the 19th gigaelectronvolts. If the Higgs would be that heavy, and if it would acquire all the masses of the other things which it could have, then it would create a mini black hole. Basically, the gravity there would be so strong that even light would be pulled in. And photons are massless. How's it working in the first place? This isn't the universe we live in. There are not micro black holes created whenever two fundamental particles come together. Instead, the Higgs is strangely tiny. Because the Higgs sets the tone for the mass of all the fundamental particles, none of the fundamental particles, electrons, quarks, neutrinos, and so on, are anywhere near the mass they ought to be. The Higgs is setting the mass which the other particles have. The Higgs is deciding how much, or is responsible for how much mass the electron, quarks, neutrinos, and the others have. And therefore, they don't have so much as they had to have. This fundamental head scratcher is known as the hierarchy problem. Okay, and that is what we don't understand. What gives one way to avert this disaster? What gives? Is that an expression? What gives? What gives? One way to avert this disaster is to set the strength of virtual particle fluctuations that cause the problem so they all cancel out, reigning in the Higgs mass and making the universe more like the one we see. Now that sentence again. One way to avert this disaster is to set the strength of virtual particle fluctuations that cause the problem so they all cancel out, reigning in the Higgs mass and making the universe more like the one we see. Okay, let's just go on with the next. The only way to do that while retaining a semblance of theoretical dignity, says CERN theorist Guido Altarelli, is to invoke a conspiracy brought about by a suitable new symmetry of nature. But where you have a conspiracy, you must have conspirators. So I think we need a new theory. I don't really get it. We need a conspiracy brought about by a suitable new symmetry of nature. I think we said we need a new rule to explain what's happening here. Traditionally, most physicists see both conspirators and hypothetical superpartner particles as sparticles, predicted by the theory of supersymmetry. The problem is that the Large Hadron Collider so far has failed to see any of the expected evidence for these particles. So there were some people who made up new particles because it wasn't fitting. So basically we're having a calculation. We're having 2 plus 2 equals 5. And because it doesn't fit, we're inventing a 1. And now we're having 2 plus 2 plus 1 equals 5. But we could not find in the Large Hadron Collider the 1. I think that is what we're saying. But there are conspirators who say there is a 1. Otherwise, how do we come to the 5? The problem is that the Large Hadron Collider so far has failed to see any of the evidence expected for these particles. More recently, an alternative solution has been sought in the effects of another hypothetical particle, the axion. We had axions, somewhere in biology. This is the long arm at a cell. That might also solve other outstanding problems of particle physics, such as the nature of the dark matter that dominates the cosmos. Okay, we're having an idea, a new particle, the axion. The weirdest scenario of them all, though, is if there is nothing but tumbleweed between the energies in which a standard model holds firm in both of the Planck scale, the quantum field theories and Einstein's gravity break down, no evidence of any new particle or mechanism that could drain the Higgs mass. Let's read it again. The sentence starts here. The weirdest scenario of them all, though, is if there is nothing but tumbleweed between the energies in which a standard model holds firm in both of the Planck scale, the quantum field theories and Einstein's gravity break down, no evidence of any new particle or mechanism that could drain the Higgs mass. I don't know the expression tumbleweed. Maybe it's expensive. Whatever, something doesn't work out. How then would we explain the vast discrepancy between its actual mass and that predicted by quantum theory? So the actual mass is very much lower than the one predicted by quantum theory. Quantum theory, it has a mass of 1 gram, so of 10 to the 29 gigaelectron. The others say just 100 gigaelectron. One solution is to just accept it. If things weren't that way, the masses of all the particles and the interactions strengths would be very different. Matter as we know, it wouldn't exist, and we wouldn't be here to worry about such questions. Such anthropic reasoning, which uses our existence to exclude certain properties of the universe that might have been possible, is often linked with the concept of a multiverse. The idea that there are innumerable universes out there where all the other possible physics goes on. So there's a multiverse, another universe, and where is the physics happening to balance out the physics which is running wrong in the universe in which humans are. That is actually not such a bad idea. On the answer, it's better than just to accept it. To many physicists, it is a cop-out. That's another expression. It looks as if it's an excuse to give up a deeper explanation of the world, and we don't want to give up. So we're saying, that says John Butterworth at the University College of London, and John Butterworth says, that's too easy. You just have another idea of the multiverse, balancing it out what is happening in the universe in which the humans are. You just want to go the simpler way, because where you come to research, you don't know where that is. You have to work harder. The problem and the solution for it is here pure. But a second fact about the new particles gives a renewed pause for thought. Not only is its 125 gigaelectronvolt mass vastly less than it should be, it is also about as small as it can possibly be without dragging the universe into another catastrophic transition. So it has way less mass as it should have. It's the first thing. The other thing is it should drag the universe into another catastrophic transition. Now we won't know why that isn't happening. If it were just a few gigaelectronvolt lighter, the strength of Higgs interactions would change in such a way that the lowest energy state of a vacuum would dip below zero. Would change that the lowest energy state of a vacuum would dip below zero. If the Higgs had just 124 gigaelectronvolt or something, then the energy of a vacuum place would be less than zero. Would it even a double vacuum? How would it look like? Would it be an energy detector? A vacuum is already, what is a vacuum? A vacuum there's nothing, so it is putting things in. Would it be an energy magnet? The universe could then, at some surprise moment, tunnel into this bizarre state, again instantly changing the entire configuration of the particles and forces and obliterating structures such as atoms. What about a controlled energy minus vacuum in a reactor to create electricity? As things stand, the universe is seemingly teetering on the cusp of eternal stability and total ruin. So I was saying, it's just splitting hairs between falling into total obliterating and eternal stability. It's an interesting coincidence that we are right on the border between these two phases, says CERN theorist Jean Gutis, who set about calculating the implications of the 125 gigaelectronvolt Higgs as soon as the first strong hints came out of the Large Hadron Collider a decade ago. So he or she was the first person thinking about what that might mean, that the Higgs has just 125 gigaelectronvolt, and now that's predicted 10 to the 19th gigaelectronvolt. Any new particle could change the game once more, he stresses. The slightest hint of new physics, and my calculations will be forgotten. So he says, if you find the axiom of what it was, then no one will remember all the calculations he did. But as long as we don't have that hint, it remains an unsettling prospect that an oddly light Higgs could hold the seeds of the universe's destructions. He's saying, what if as one day a Higgs would just have 124 gigaelectronvolts, then the whole universe would become a tunnel and be totally obliterated, whatever it means. That was a particle physics part. If you are here for particle physics, you can go directly to the next one, particle physics. If you stay here and participate in the 1.5 minute yoga, then it's better here. If you just stand together, leave in the outside. Out and down. In and up. Out and down. In and up. Hold up to the side. In and up. Hold up to the other side. In and up. Hold, make an inch space between your feet. In and up on the toes. Hold and down. In and up. Out on the other side, heels down. In and up. Out and down. In and up. Out with the hands on the sides, down, feet together. Breathe in with the right leg. Breathe out, stretch left leg. In, change. Out bend the right, left leg. In middle. Out down. Make a hand with space between the feet. Stretch the way to the heels. Breathe in and down. Out and up. In and down. Out and up. Take count on the elbows. Gentle up from side to side. Feet together, hands down to the ground. Open the right hand to the sky, bend the left knee, look to the sky. In, down, out, down. Breathe in, left hand up to the sky. Bend the right knee, look up and down. Breathe in, bring a straight back, halfway up. Out and down. Again, halfway up, straight back. Out and down. Breathe in, the hands again up. Draw the shoulders, the hands back, draw the shoulder blades together. In and up. Intertwine the fingers to reach high. Breathe out, reach your front over back. In and up, in and out, in and out. Out and front. In and up. Lean back with long arms, strong shoulders down. Our elbows down. In and up. Out and back with long arms. In and up. Out and down. In and up with the arms. Bring the hands to touch, allow the hands down to heart center. That was my 2-minute yoga, 100-second yoga. I thank you very much, and until next time.